5.1, ratios and proportions. All right, so by the end of the period, you'll be able to set up and solve word problems using ratios and proportions. Let's quickly review proportions from last school year, or even for some of you, a couple years ago. Okay? Whenever you're giving a proportion to solve, you will cross multiply. So what I would like you to do is on your own paper, I want you to go ahead and try to do these 6 questions. So I'm going to work them out here, but I want you to pause the video here. And when you unpause it, or I'm going to show you the answers very shortly. So try these questions, pause the video, okay? Here are your answers. Now, if you remember back in the day when you had this, the way to solve a proportion is to cross multiply. Remembering that, ooh, I forgot to write it here. Remembering that proportion is basically 2 ratios set equal, or another way to say that, it's 2 fractions set equal to each other. So you'll cross multiply. So if you look at 21, 22, and 23, that's exactly what happened. And you can see the 15x equals 30 on 21, you know, the 5y equals 20 there, and the 2400 equals 30m. Again, it's by cross multiplication, and then we're just solving with the algebra. Where you need to be careful are on these bottom 3 questions, 24, 25, and 26. You'll notice that it isn't just one number in the denominator here and here on number 24. It's actually what's called a binomial. We have x plus 2, that's binomial. We have x plus 5. So when you cross multiply, you take 16 times x and by 2. So maybe use a different color here. You took 16 times the x and times the 2. That's why it's 16x and it's 32. And then we took the 4 times the x and it gave me 4x, and the 4 times the 5, which just gave me the 20 on there. Okay, again, you can see that again, the 15y here on problem 25 and the negative 30. Okay, and then you can see on here the 3y minus 9 because it was 3 times y and 3 times negative 3. Again, the biggest mistake students will make is they'll forget to multiply everything together. So like on 24, one of the mistakes students tend to make is they would take 4 times x, but they wouldn't multiply it by the 5. So instead of getting 4x plus 20, they get 4x plus 5, which is obviously wrong. Anyway, here are your answers. You can check them out. Okay, so I kind of did these. Normally we do this when we're actually present here. We look around the classroom, but so what I did is I just filled in some numbers here. So I'm going to explain what we're looking at here. Okay, what is the ratio of staff to students present today? So let's say I'm the only teacher in the room, and let's say we had a medium small class of 20 students. We would say the ratio is 1 to 20. That's how we have this written with this colon here. All right. Now, again, you can also write this as a fraction, 1 over 20, which is helpful for when we actually have to use it and make a proportion out of it. Question 2, what is the ratio total number of left-handed students in the total number of students present today? So again, if we had 20 students here, and let's say we looked around the room and there was 3 of them that were lefties. So it would be 3 to 20, or 3 over 20, which would obviously mean there were 17 right-handed students. Number 3, the ratio of students wearing long sleeves to the number of students wearing short sleeves. So again, you'll see here that it's 14 to 20 here. So we have ratio of students wearing long sleeves to the ratio of students wearing short sleeves. So actually, this is a typo. If I said long sleeves to short sleeves and we said there were 20 students, this shouldn't be 20. This should be, I made this mistake on purpose. No, I really didn't. It should be 6. And that would be saying that there were 14 wearing long sleeves and 6 wearing short sleeves. And so instead of being 14 over 20, it would be 14 over 6. Okay, now you'll notice that I did simplify to 7 over 10. This would actually simplify to 7 over 3, because we would take a 2 out of both. So we could have written this as 7 to 3 like that, long sleeve to short sleeve. So anyway, I pardon my math mistake. Okay, so we're going to use the information from problem 2. And problem 2 was talking about the left-handed students. And if you remember the left-handed students, it was 3 to 20. We had 3 left-hand students to 20 total students in the classroom. So if you get a set of data like this or information like this, you can then, if you think your sample is a good enough sample to represent like, oh, all the kids in the school, we could say, how many left-handed kids do you think are in school if they have the same ratio? So we know our ratio is 3 to 20. Well, the whole school has 1,800 students. So how many would you expect to be left-handed? Well, again, remember, it was 3 lefties over 20 total. So you want to know how many lefties will be in the entire school. We don't know, so we're going to call that X over the total number of students in the school, which is 1,800. So if I'm going to go ahead, here and try to figure this out, this is how you would set the proportion up. You would have 3 over 20, because that's our proportion we have, 3 lefties out of the 20 students in class. And then we have the unknown amount of students in the population, the X, over the total population was 1,800. Now, once you set this proportion up, you cross multiply and solve. You can see my algebra there. I got 270 lefties. So if we expect the student population to hold to the same amount of lefties as are in the classroom, this is what you'd have. And I would guess that it's probably not this high, but I don't know. I've never really looked at data like that. I'm a lefty, by the way. So again, let's go ahead and look at how we can use this example. So a scale model of a car is 10 inches long to 5 inches high. The actual car is 60 inches tall. What is the length of the actual car? So thinking about how this is written, it's the length of the car over the length of the model equals the height of the car over the height of the model. Again, that's how we explained it, right? Or that's how we can look at it. So what would it look like in numbers? Well, what don't we know? We don't know the length of the car, right? We have no idea. So we're going to let that be X, and that's why we have X written here on the proportion. Okay, and then what do we know? Do we know the length of the model? Yeah, it tells us right here in the direction it's 10 inches long. So that's why the 10's here. We also know that the actual car is 60 inches tall, which is written over here. And then the model is 5, so that's why we have it written here. And so then you would just cross multiply this. Here's the deal. Again, we are trying to find the length of the actual car. When you set up your proportion, you have to be consistent. So if this 60 inches represents the real height, then, and it's on top of this fraction here on the right, then this X better represent a real measure. In this case, the unknown measure of the length is what we call X. All right, so it's being consistent. All right, the only way to get better at this is to practice it, and we'll practice it. So we have it set up here. You can cross multiply. It's 5X equals 600. You get that the actual length of the car is 120 inches long. Now, again, I am expecting maybe not a perfect sentence, but some sort of writing explaining what happened or what our answer was. The largest submarines in the United States Navy are of the Ohio class. Each submarine is 560 feet long. You purchased a scale model of one of the submarines. The package states that it's 1 inch to 16 feet. What is the length of the completed model? So for every 1 inch, and I started a proportion here, for every 1 inch you get 16 feet. Well, here's the deal. The feet are what's it actually mean, or actually is, and the inches are what the model is. The only time that we would have a larger unit be in the model is like if we made a model like in your chemistry or science class of like of an atom or a molecule or something. Obviously, you're making it way bigger than it really is. But typically when we talk about a scale model, your model is smaller than the real thing, usually. Okay, so we have 1 inch to 16 feet. 16 feet, again, is the real deal. And so the 16's in the denominator. So hopefully you can kind of get an idea of where the 560 feet need to go. It should go into the denominator. Again, make sure units match. I mean, that's another big thing. I had inches on top, feet on bottom. Okay. Oh, look, it's 560 feet. Okay, that'll be on bottom. Now, what is the length of the completed model? Well, we don't know. We'll call it X. And so now you're going to cross multiply. So we end up with 16x, because that's 16 times x, equals 1 times 560. Then you divide by 16, I get x to be 35. So again, I'm going to totally run out of space here. The length of completed model is, again, if the question's in a sentence, you need to write the answer in a sentence as well. 35, and again, think about what my units were, right? The model was in inches. So it's 35 inches. If the model is approximately 5 inches tall, what's the height of the actual submarine? Okay, again, remember, it was inches on top, feet on bottom. So the model is 5 inches. I don't know the real height. So you should have this set up this way. You cross multiply, you get x is equal to, because 1 times x is x, 16 times 5, you get 80. I don't need to divide by anything, so there's actually your answer. Okay, so what is the height of the actual submarine? Again, it was in the denominator. Denominator was feet, right? So the height is 80 feet. Go ahead and try these two on your own. Go ahead, and I'm going to go ahead and work it out real quick for you. So pause the video now. So as we look at this, it says we are wished to represent the length of room in a 5-inch segment here. And we know the actual room is 18 feet long. So you can write this as a scale of length, scale length to actual length. Well, the scale length is 5 and the actual length is 18. So it's 5 to 18 or 5 over 18 as a fraction. So then they say, hey, what if the actual thing is 54 feet? So instead of being 18, okay, it's 54. So it's 5 to 18. We're using that scale factor equal to, well, the blueprint x on top, okay, divided by the actual, which is 54. Then you would cross multiply and solve for x. So you would end up with 18x equals 270. Divide 18 on both sides. X is 15. So how long would the segment would the architect use in their blueprint? It would be 15 inches. So the architect, you need to write it out, right? Would use 15 inches in his blueprint. Okay, Milton and San Jose are 9 inches apart on a map that has a scale of 1 inch is 13 miles. So how far apart are the real cities? Well, again, we're using our scale 1 inch to 13 miles. We know that it's 9 inches on the map. So 9 is on top for inches, because that's what we don't know. 13 is on bottom for miles. So it's 1 over 13 equals 9 over x. And then again, once again, you'd be cross multiplying. So you'd have x is equal to 13 times 9. You get 117 miles. So how far apart are the real cities? The cities are 117 miles apart. Fairview and Madison are 36 kilometers from each other. How far apart would the cities be on a map with a scale of 1 centimeter equals 12 kilometers? So again, we're converting from kilometers to centimeters here. Okay, notice that I wrote this scale down already. So again, kilometers is the real distance. That's going on bottom. Our unknown, how far apart would they be on the map, is x. You cross multiply, you get 12x is equal to 36 from cross multiplication. X is 3. Divide both sides by 12 there. So how far apart they would be? They would, it's not right. Okay. They would be 3 centimeters apart. Okay, now we're going to kind of up the difficulty of these questions. The perimeter of a rectangle is rectangle JKLM is 56 centimeters. That means when I take both lengths, so the top and bottom, they're both L's, and both widths, the left and the right, which are W, when I take L plus W plus W, I'm going to get 56. Or another way to write this is 2L plus 2W equals 56 because I combine like terms. All right, now let's go ahead and keep going with this. So the ratio of JK to KL is 4 to 3. That means for every 4 in the length, there's 3 in the width. And so we need to actually attach a ratio to this. So again, it's 4/3 like this. So we're going to call it for every 4x, there's 3x there. Now, the reason why we're writing the variable x in there is x represents whatever measure is going to go into that. Okay, so we're going to use this 4x and this 3x here. So what we're going to do is instead of L in my 2L, I'm going to write 4x. So it's 2, and then this will be a 4x in place of the L. And instead of the W, I'm going to write 3x. Again, this is counting for the relationship that exists between the length and the width. So I took this 4x and this 3x. This is a little weird to think about at first, okay? And you may need to watch this a couple times, this portion of the video, to understand what we did. Again, I used my ratio that I knew from the length and the width over here, the 4/3, to come up with the 4x and the 3x, which then I replace the L and the W with. Now what this turns into then is 8x plus 6x is equal to 56. And now we have one equation with one variable instead of one equation with two variables. You combine like terms, you get 14x is equal to 56. You get x to be 4. Now, you think, okay, good, I'm done. No, you're not. It asks you for the length and the width. So to calculate the length and the width of the rectangle, you actually plug this 4 in for the x's there and there. So you get the length to be 16 and the width to be 12 because 4 times 3 is 12 and 4 times 4, 16. Now, we're not done. Let's check it. If I take 16 and times it by 2, and I take 12 and times it by 2, and add them together, you should get 56, which is what we told you the perimeter should be at the beginning. So again, that's a way you can check your work. And I kind of ran out of space here, so I'm going to write at the top. The length, let's try that again. The length, goodness gracious. Is 16 centimeters, and the width is 12 centimeters. It was really nice having a picture. So drawing a picture, if there's one not given to you, is really important. The perimeter of a rectangle yard is 80 feet. So again, we have a length and we have a width, right? 2 L's and 2 W's. The ratio of the length of the yard of the ratio of the length to the width of the yard is 3 to 5. So my picture is going to look a little weird because the way I drew it, but that means that L is going to be 3x and W is going to be 5x. Again, the reason why length is first here, and we have it written out in words, and width was second. So it means when I have my ratio written there, length is first and width is second. So L is 3x and W is 5x. Now, we just calculated on the previous slide, if I know my perimeter is 80 feet here, that means that 2L plus 2W equals 80. And so now instead of an L and a W, I'm going to be using a 3x because that's what my ratio told me the L was. And I'm going to use, instead of the W, a 5x because that's what they told me with my ratio there, what the W was going to be. So it's 6x plus 10x equals 80. It's 16x equals 80. We want to go ahead and divide 16. Again, what's hard about this is it's multiple steps. We get x to be 5. Now, what is that? That's just basically the proportion we're using. So I know my L is 3 times 5. So my length is 3 times x. X is 5. So it's 15. And my units on this were yards. My width is, well, again, x is 5. Width is 5x, 25 yards. Now, once again, we can double check this. Take 15 times 2 plus 25 times 2. You get 80. My perimeter is correct. Okay, now we're going to add a layer of difficulty. We're going to talk about a triangle. Now we have the extended ratio, so the lengths of the side of extended ratio of a triangle are 3 to 5 to 6. That just means, again, just like before, how when we had like 3 to 5, it was 3x and 5x for the length and the width. This is literally, quite literally, you're going to slap. This is going to be 3x. This will be 5x. This will be 6x. That's literally what you're going to say for the sides of this triangle. Now, we know the perimeter is 98 inches. So it's a little easier with a triangle because literally when I ask for the perimeter of a triangle, it's basically all the sides added up. So you're going to take 3x plus 5x plus 6x. It's that equal to 98. Notice our units are in inches here. So you want to calculate the longest side. Obviously, the longest side will be the 6 times x. So once you calculate x, you take 6 times it, and there's your answer. So when we combine like terms, you get 14x divided by 14. You get x to be 7. Again, just take 7 times 6, and the longest side is 42 inches. All right, so let's try another example of a triangle. So a triangle with the sides with the extended ratio of 4, 7, 9. So again, think of this, it's 4x, 7x, 9x. It says, what are the lengths of the sides? So now we're not, the perimeter is 60 centimeters. What are the lengths of the sides? So it's going to be 4x plus 7x plus 9x is equal to 60. Now, if we go back, remember, okay, we were on the previous question, we were just asking for the longest side. Now it's asking for all the sides. So you got to find them all. All right, so you're going to combine your like terms. So we combine our like terms, we get 20x. We divide by 20 on both sides, we get x to be 3. Once you get x to be 3, it says all the length of the sides. So you're plugging a 3 in for each of these. So this side over here, it's going to be 4 times 3, so it's 12. Our units on here is centimeters, so it's 12 centimeters. The bottom side on here, again, it's going to be 9 times 3. Okay, so 27 centimeters. All right, and then the top, it's going to be 21 centimeters. So we got 27 centimeters for one side, 12 centimeters, and then 21. So the lengths of the sides are 12 centimeters, 21 centimeters, and 27 centimeters. Okay, so you will try this question now. I will write out the answer and briefly explain it. I'm going to pause it right now. Or sorry, you should pause it right now to get the answer. Okay, so I drew the picture. I put 5x on the top and bottom and 8x on the left and right. The reason I did that is it says the ratio of length to width is 5 to 8. So the length can be 5x and the width 8x. Again, I used the formula that we know that 2L plus 2W equals 169. So that's 2 times 5x. That's 2 times 8x. When you solve for x, you get x to be 6.5. And then I take 6.5 and I times it by 5. And I got my answer. The length is 32.5 feet. Go ahead and try this one on your own. Pause the video because the next thing you're going to see is the answer. Okay, I drew the triangle. We knew the ratio of the sides were 2 to 4 to 4. So 2x, 4x, and 4x. The perimeter is 50. So 2x plus 4x equals 50 centimeters. Combine like terms, solve for x. X is 5. Now it asks you on here, what's the length of the shortest side? So 5 times 2, that'll be the shortest side, it's 10 centimeters. You can check that this is right because you can take 5 times 4 and get 20. So that means these two sides here and here are both 20. So 20 plus 20 is 40, plus another 10 for the shortest side is 50. So that's a way you can kind of check, are you doing it right or not?